Good afternoon, excuse me. It's afternoon for me, not afternoon for you. It's Thursday morning for you. It's Wednesday afternoon for me. But anyway, good morning, fifth grade. Hopefully you're doing okay today. Today is Thursday, like I said. We're a little past halfway in the week. Let's make sure that we're really trying our best on these last couple of math lessons in the PLP for the rest of the week. We need to make sure that we're getting these problems finished and we're getting these problems done. And of course, we're reaching out and asking questions and getting help whenever we need it. I encourage you guys to continue to do that. I didn't have as many people reach out and ask for questions yesterday. I think a couple people found my YouTube video pretty useful. Um, so if you're one of those kids, and that was helpful for you, awesome. But if you're one of those friends that still needs extra help, I should see you requesting for help in the breakout room. You should be asking questions whenever you guys get a chance. Anyway, it's awesome to see your face. It's good that your cameras are on. It's good that you're with me. You guys have been doing an awesome job about this. Once again, body language is key, guys. I need to be able to see that you're with me and learning and focusing, and that's kind of the only way that I can see if you're being patient with this and taking your time and looking like you're trying to learn. That's really important. Anyway, let's kind of talk about our goal for this today. Like lesson 83 from yesterday, lesson 84 kind of builds on what we already talked about from the last couple of days. The last couple of days, we really worked on looking at multiplication of fractions, as scaling. And what I mean by scaling is determining whether or not our number, our first factor, gets bigger or smaller depending on the number that it's multiplied by. Today, we're going to do that again, except instead of not solving it and just telling if it's bigger or smaller, today we're going to solve it, and our answer will tell us whether or not our first factor gets bigger or smaller, depending on what our answer is, and of course, depending on what we're multiplying by. Really quick, before I solve this, I just kind of want to review our rule. If you think about all of our problems that we've solved so far, we've had a factor. So sometimes this factor, or usually this factor, has been a whole number. So it could be 1, 2, 3, 4. We've usually done a factor times a fraction. And whenever we have a factor times a fraction, and keep in mind, a regular fraction, not an improper fraction, but whenever we have a factor times a fraction, we know that all fractions that are not improper fall somewhere on the number line between 0 and 1. 3/4 falls somewhere right here. 3/5 might fall somewhere right here. Doesn't matter what our fraction is. 1/10 might fall all the way down here. But because we have a fraction where the numerator is smaller than the denominator, we have a fraction that's between 0 and 1. And anytime we have a fraction between 0 and 1 that we're multiplying our factor by, we're scaling down. We are scaling down, meaning that our product, you guys might have seen that P yesterday, that can either stand for product or placeholder, whatever you want to think of. But our product gets smaller whenever we multiply by a fraction. Whenever we have an improper fraction or a mixed number, this product is getting larger than our factor. So if we have a factor times a mixed number, and we'll just use 1 2/3. Because 1 2/3 on our number line is larger than 1, because it falls somewhere right here, because it's bigger than 1, our answer, our product, will scale up. It'll be larger than our original factor that we have here, our original whole number. So that's what scaling up and scaling down is, folks. We're scaling down whenever we're multiplying by a regular fraction, so a number between 0 and 1. And we're scaling up if we're multiplying our factor by a mixed number, or an improper fraction, or any number that's larger than 1, or scaling up. Let's take a look at the problem we have, and I'm going to erase everything I just drew. That was just an example to kind of show you guys. Use my eraser tool, actually. Quick little mini lesson right there to kind of review what we've talked about. Now we're going to solve this, and we're going to use our numbers. This one we have, it says, Mrs. Smith has 3 yards of border paper. She needs 2.5 times as much to go around the bulletin board. How many yards of border paper does Mrs. Smith need? First of all, guys, border paper is just kind of the stuff that teachers a lot of times put around the outside of their bulletin board, kind of like this little blue line I'm drawing around this fake bulletin board that I'm making. So it's saying that she has 3 yards of this, and she needs 2.5 times as much. Those are our 2 pieces of information. So it's saying that she has 3 yards. That's what we're starting with, 3 yards. She needs 2.5 times as much to go around the bulletin board. So that means we need more. In order for us to need more, to get more, we have to multiply this mixed number right here times our whole number that we have right here, 3 yards. So we can set this up like 3 times 2.5, like we have been. And as we solve this, we need to remember that we have to convert our mixed number to an improper fraction, and we do that by doing 2 times 2 plus 1. So 2 times 2, which is 4. I know it kind of looks like a Z, but it's supposed to be a 2. And then, of course, adding the 1 in our numerator. That's what we have left over in our numerator. What we're doing is we're taking 2 over 2 twice. That's what we're doing when we multiply this 2 and 2 together, and then adding our 1/2 right here. Because remember, multiplication is just repeated addition. So we have 2 over 2, 2 over 2, that gives us 4 over 2, or 2 wholes, which explains where we get this big 2 from. And then we have 1/2 left over. So when we solve this, we get 5 over 2 for our improper fraction. And I know I stopped filling this out up over here, but really all we have to do is just take our 4 and then add our 1, and we get the 5 for our numerator. But I did it down here, so you guys don't have to worry about that. Alrighty, folks. As we solve this, once we get 5 over 2, we can drop that down, and we can remember that it's really 3 over 1 times 5 over 2. When we do 3 times 5, it looks like an S, I know. We get 15. And when we do 2 times 1, or 1 times 2, we get 2. 2 goes into 15 7 times, because 2 times 7 is 14. And we have 1 left over. The difference between 14 and 15 is 1. So really what we get is 7 and 1/2. She needs 7 and 1/2 yards of bulletin board paper in order for her to go all the way around. And that's how you solve these problems, folks.